All right, thanks again, Travis, and thank you, Lily, for an excellent presentation, which I think in many ways is a great lead into what I have to present here today. So my title is Thematic Mapping in Augmented Reality, Challenges and Opportunities. At least that's what it is in the program. Okay. Have to make a slight amendment to that. It was a little too broad, so I narrowed my presentation, my talk here today, to focus on thematic mapping for flood hazards, which is a major focus of my work. My location, my office on Galveston, we're well known for impacts of storm surge and other flood hazards. The images shown here actually are some of the damage caused by Hurricane Ike back in 2008. And so I've been thinking for several years now about how to develop better, more engaging tools to communicate this hazard for maybe new residents to the area, folks who have not yet been through a large hurricane storm surge event. And one of the things I've been exploring is augmented reality tools for communicating that hazard. So my main question that's been motivating the talk today is how can cartographic design principles for thematic maps inform design of geolocated mobile AR tools for flood hazards? I found both in the work that I've done previously and in looking at work that others have done, which I'll show a quick survey of today, a lot of the tools that have been produced thus far in the geolocated mobile augmented reality space tend to be a little clunky, not so user-friendly, and maybe not even as aesthetically pleasing as one might hope for. And I think some of that is just the tools themselves are maybe not quite mature just yet. And I believe also perhaps the design of the tools themselves could be enhanced a bit by drawing more on some lessons from thematic map design from the cartography community. Oh, and I see that I don't have captions due to network issue. Let me resolve that. Okay, starting subtitles. Okay, so with luck, we will. Yes, okay, I think we're back in business. Wonderful. Okay, so that's the question that's motivated my work today. Plan of the talk, I'm going to tell you a bit about my own work in this area, 2 AR projects, one that I presented on here at NACIS previously, so I won't say too much about that, but I want to show you a little bit of the work I've done in this area in the past. And then the real motivation for this work that I'm presenting today is a new AR project that I'm planning for at the moment. And as part of that, I would like to survey the design of existing AR tools for flooding to get a better sense of what design approaches have been used and possible areas of improvement. From that survey, I've identified some trends, gaps, and next steps that I'll share with you. Okay, so yeah, the motivation. 2 AR projects, my prior work, which used the Wikitude platform and was marker-based, and a new direction, which is going to use Apple's AR kit. This is the work I presented previously, point-based markers for storm surge flooding. Took the building centroids for all locations in Galveston, but the example is shown here from the Texas A&M Galveston campus, and then extracted flood depth information from some rasterized AdCirc modeling results for storm surge and sea level rise scenarios. And then, as I said, got the average flood depth within those building footprints and placed a marker at each building location with flood depth for that scenario shown relative to the height of the user. The user, when launching the application, was asked to enter their height. And users found this kind of interesting and fun to work with. I did a quick user survey on it. I presented those results at NACIS several years ago. But they found the technology also a little bit disorienting, didn't do a great job of tracking smoothly and maintaining the marker position relative to the associated buildings. So certainly there was some room for improvement in terms of the quality of user interaction and also the data display. So just a little bit more detail on what those markers look like. If the water happened to be above your head, I put that little caret on top with some text indicating just how far above. So that's a real bad day in Galveston if you've got storm surge 2 feet above your head. Okay, so the new project, transitioning over to Apple ARKit. This is motivated by a couple of things. For one thing, Wikitude is now officially no longer supported. So I wanted to move to a new platform, something a little bit more robust. I do a lot of my work in the Apple ecosystem, which has some advantages and disadvantages, but ARKit is a pretty robust platform for this kind of thing. And so I've been working through the Apple tutorial for building an AR application. And it allows for much more precise geo-tracking than was allowed in Wikitude. Identifies ground coordinates or 3D building features at a tapped location. Faster, better 3D support, free and still supported, which is great. The most precise geo-tracking, though, is only available in select urban areas. So Houston is one, which is just north of where I live and work. So that's great, but not Galveston just yet, which is less than ideal. And also, as I said, it's iOS only, which is not wonderful in terms of making these tools available to everyone. So I won't go into too much detail here, but I'm starting to plan for what some of the features of this new app might look like. I want to rely on, at least to start, that same data source, my AdCirc flood modeling for different surge and sea level rise scenarios. Probably to start, still have a point marker based approach, but maybe use 3D markers and allow placement both at a user-selected location on the ground and maybe also the side of the building based on where users tap on the screen. And the ARKit interface does a good job of supporting that out of the box, which is nice. The last bullet, though, here is what I really want to focus on today, the design of the markers. Well, do I want to use markers? Do I want to go to a more volume-based approach? Do some occlusion modeling so that I can present a more realistic view of storm surge flooding. Do I want to go 3D? Do I want to keep something that's user height adjusted? Yeah, so what do I want to do there? So I thought, okay, really what I need to do is survey the literature, get a better handle on what some others have previously done in this space. And so that's where I am now in the next steps for developing this ARKit application. So this is what I did, I've started to do over the last couple of weeks. I've been a little slower getting this up and running than I'd hoped. But I've started with a Google Scholar review, looking for articles that involve the term augmented reality, flood or flooding, only looking at mobile applications. I don't want tabletop AR. I don't want virtual reality. And at least for the first pass, I was looking at articles that at least in some way tried to engage with cartography or cartographic approaches, thus the final search term there. So this search returned over 1,500 results. I then manually filtered that by looking through a good number of them to select only those that specifically focused on the development of new tools with geolocated AR display for mobile devices. And surprisingly, a few of the articles met those criteria. So I may need to expand this lit review in the future to get a more inclusive subset. Potentially, instead of looking at the academic literature, maybe pulling in some more examples from data journalism, as Lily suggested. I think that's a great direction. So in reviewing these, I looked at the dimensionality of the displays produced, point, surface, or volume. Some of the visual variables used in the AR space, specifically the visual variables used to convey information about flood zones or flood depth. And in the future, I don't consider it today, but I want to look at some of those other elements surrounding the flood display, marginalia, interface elements, other contextual elements. And the goal was to identify trends and gaps and consider opportunities for applying cartographic design principles, both to my own project and other similar projects going forward. So here are the results that I found. I actually only found 8 articles out of that set that really met the criteria, so I probably need to broaden this a bit. But the first results started to appear in the literature back in 2015. And the most recent ones are from this year, 2024. So the next 2 slides summarize these. Most of them, as you might expect, present the flood information in terms of a volume that's imposed upon the camera display. But some of the earlier work also just applies a surface to the ground and uses hue to indicate in a flood risk zone versus not in a flood risk zone. There are still some point marker-based approaches that are kind of similar in some ways to what I'd done previously in this space. Looking at the more recent results from 2022 and this year, again, we see a lot of volumetric-based approaches. This last one, I think, is actually kind of cool. I like the use of volume to, actually show flood waters in the scene, augment with those flood waters. It's a more realistic approach in some ways, but I do wonder if, for users, something that covers a little bit less of the display, but really adds an annotation and augmentation just to the most relevant feature, perhaps a corner of a building here, showing a couple different scenarios simultaneously with flood lines added to the building. Something like that, I think, might be a more effective and data-dense way to communicate multiple scenarios. Yeah, so one thing I'm considering is there's a trade-off here between trying to obtain a more realistic display versus taking advantage of the fact that we're working in this augmented space where really we're not constrained by going for something that's realistic. We can use visual variables and other design principles to create displays that more efficiently and effectively communicate potentially lots of information simultaneously. So I did some really quick work in Excel to try to summarize the dimensionality and visual variables used in these 8 examples that I found. And as I said, the volumetric displays were by far the most prominent. I still had a couple using those point-based markers, and then that one from 2024 using lines. Visual variables, hue by far the most common to indicate flooded versus non-flooded areas, often just that blue naturalistic water volume, and especially emphasis given to the surface, the upper surface of that volume. I didn't include transparency here. I know often that's included as a visual variable and did show up, but I see that more as something that's used to enhance the realism of the display as opposed to something to communicate the depth of the flooding or the presence of the flooding. So, yep, height and shape, especially shape, was used wherever those point markers were used. Shape was also used as well, which again, not so surprising. Okay, so where do we go from here? As shown on the last slide, we're not using really all that many visual variables to communicate information about the flood hazard itself. So maybe there's potential to integrate some of the others. Especially perhaps something like orientation to show direction of flow. So that's something I'll be thinking about. I've already mentioned the next bullet, the trade-offs between more realistic and stylized designs. I think there's potential to maybe move away from simply going for the most realistic possible display of floodwaters on a landscape by adjusting the height of a volume for those floodwaters. That, I think that's great and potentially quite engaging for users, but is it really the clearest, most efficient way to display and communicate this information? Depends on audience, I would imagine, but it's something I hope to explore further. Also, the potential for linked views. So already we see this in some products, again, like this example from 2024, the inclusion of a more traditional web map product alongside the AR view. Since we are working with mobile devices, screen size is a consideration, so it might be hard to include a map and a chart and the AR view all in one display, but thinking about how to add some of those elements efficiently and in a way that is user-friendly is something that I'll be doing going forward. And I'd like to expand the review of prior AR design work beyond the 8 or so articles covered here to include maybe some examples from journalism and perhaps also broaden the search to include hazards other than flooding. And there also are, as I've noted here, many or at least several attempts that have been made previously to specifically apply cartographic approaches to AR design. And so I'll be reviewing those more closely going forward. Here are my references for the talk today. And thank you so much for your attention. I appreciate it. And apologies for the technical issues.
Do we have any questions for David? All right, if you do think of any, definitely approach him. You'll be available throughout the day.